And hello everybody, hope you can hear me well today, and welcome to this lesson number 7, I guess, of the motion graphic class for beginner. Today we're gonna go in a step further. Yesterday we tried to make a planetary animation, very simple, with some simple material. Let me reload it so I can show that to you again. So we did this animation here yesterday, and we added a few material, and today we're gonna be talking about lights, so simple lights in Blender. They can be used both in 2D or 3D. It's the same concept. It just depends on how you watch at the scene. Even the scene that we made yesterday, it will work in 2D exactly as in 3D. So it's exactly the same idea. So before adding lights and make this sun, this star really shine, I'm going to show you what kind of lights we can make in Blender and what are lights. I think it's clearly easy what are lights. They are visualized in different way in Blender. Usually this light, it's called point light, and it's I would say the most common one that you will use. And we'll start with that, and that's also the reason why you have this kind of light in the default scene with the default cube. In order to visualize the lights, you want to go in here in viewport shading, because the viewport shading, the rendered viewport shading, it's the only one that will show you the real lights. Otherwise you will have lights coming from the environment maps. We're gonna see how to add more environment map, and you can also enable the scene lights in this material preview mode, but I want to go to the rendered preview because it's the one that it's closer to the final result. Or if we are using Eevee, as we are, it's actually the final result you'll get. So if something looks good in this viewport shading, it will gonna be exactly the same good look in the final render. Let's load something that in the scene, something that makes things easier to understand. We have a plane here, and as we move the light, let's move the light only on his X and Y planes. You can see that the lights, it's illuminating only those parts, and everything else it's in shade. A point light, it's something like a star or a bulb without any shade around. So it's a light emitted by a point, a single point, in each direction. So all the direction around it will receive light, unless they are protected by some other object. So there is some kind of obstruction, you will get light. In real life, this kind of light probably doesn't exist much apart from the stars, because the stars have no shape, so the light is emitted from the stars everywhere. But the closest thing you get to a point light, it's a normal spherical bulb in an indoor environment. There are other kind of lights. You can change here the kind of lights, but I prefer to create because it will change also the look of it. So for example, we can create a spotlight, Let's remove this. And here's the first problem. The spotlight doesn't work too well with this render engine, so we are not gonna use. We know what is a spotlight. At the moment we are not gonna use that, but we just know that they exist. Render works with different engine to visualize the images, so if I can change these to cycles, I will have an effect that it's very faint, so I need to increase the power. And if I go back to Eevee, I'll now see it. But we're not going to work with spotlights. They're a bit more complicated. They have a target, which is where the spotlight is pointing at. But I just want to show you all the different kind of light. Then we have area light. Area light, let's make them bigger, and let's go in the settings and increase the power of the area light. It's pointing up, we want that to point down, so we'll flip it. And area light, imagine that as a, for example, as an LED light, like the studio light, the square sized LED lights, or you can imagine them as a neon light. So if you change the shape of this to something like that, and maybe scale it like this, you can have some different kind of shape of light. It's not really working well. Let me try again from scratch, so I'll show you what I mean. Area, let me raise it up and increase the power. And then I'll change the shape to rectangular. It's not really doing what we expect. And again, it's because the engine we're using is not as precise as cycles. So now you can see the difference in render. Here it's shading let me change the shape again, and let me move it closer so you can see. Okay, now you can see what is it doing here, while in Eevee it's still very blurry. It's not clearly working as expected, but anyway, you got the point. You have also this kind of lights. When you build the scene, you want sometimes to experiment with a number of different lights, exactly as in on a set, unless you know what you want from the beginning. Then we have another light which is called sun, and that's, I would say that it's kind of misleading, because the sunlight is not what you imagine that comes from a star, but it's a directional light. So the light only works in a direction. If I turn this, I don't see any specific shadow, and even if I make it smaller, I don't see any shadow. It's basically, it will give shadow once we add objects to the scene. The sun is called directional light because the sun is so big that all the lights, all the rays of light come parallel from the sun towards the earth. So they don't come from a point, as I said before, but because it's so big, it's like a massive array of points, and some of the rays of light that reach some of the rays that will reach the earth will be, the strongest one will be parallel. So this is a directional light, which is called sunlight in Blender. So where do we see how the light will really look like? So you want to activate the rendered mode, and then you want to change from EV to cycles only if you want to render in cycles. Now we are gonna do the whole course all with EV because it's much faster. So I'm gonna optimize it. We will optimize everything in the scene with the tool that work best with EV, while some other tool will only be visible in cycles. So you have a number of different tools, but we're gonna use only the one that works best with EV. So to go back, if you want to preview the lights in the scene, you have to click on render here, or if you are in material preview, you have to enable scene lights from here. These two are very simple, very similar, but it's better to keep them like this without modifying the behavior. This mode, the material preview, will use the HDRI as a source of light, while the rendered view will use the lights and an HDRI only if we add an HDRI in the image. Okay, so let's create an object in the scene, another object like a cube, which is kind of simple to understand, and then we'll just make it taller, and then we'll add a light in the scene. We'll start with a point light, and we're gonna increase the power of the light so we see something happening. The first thing you will notice is that there is shadow, so the light is working. And if we add another object, let's say here, as this is a point light, it will illuminate both sides. Okay, so exactly like a lamp you may have at home. The lamp will go everywhere unless there is something that it's obstructing the light to it's making shadow basically. Now let's change this light, and we go now with the other kind of light, area light, and let's make them very powerful. It's similar, the concept is similar, but it's illuminating only everything that is beyond the plane of the light. If I put it down, it's not illuminating this area, while a point light will illuminate everywhere. This one, it will only illuminate the direction that it's facing my light. See, you can turn it around. The shadow of a area light are quite soft, and that's mainly because there are a lot of rays coming from an area light, so you will get some area of not completely shadow. I think they're called penumbra. While with the spotlight, let's try to move the spotlight and give it a lot of, oops. Let's give the spotlight a lot of power. You will only have the shape of the spotlight. You can enlarge the cone of the spotlight. You can move the spotlight, and similarly to the area light, will only illuminate everything that is within the cone. So it's a slightly different behavior, and it's exactly what you expect from a spotlight. You can increase, of course, from the settings on the right side. This is the blend area, it's the area of penumbra. You can have it very straight, and you have a spotlight with a very very sharp edge Okay, what we want to know about these lights, let's go with the point again, which is the simplest one. First of all, sometimes they are a bit faint, you want to increase them. Is that they may not visible in all the material, so it depends on what material you have in the scene, they will react differently. Right now I have just a standard material, so I'm gonna change some of the material so you'll see how they react to these changes. You can disable shadow altogether. If you need the light just to add some feel, but you don't want that to make shadow, just to add light, you want to disable shadow. Don't forget that the lights, it's an item, it's an entity in the project, so you may have as many lights as you want. The more lights, the heavier the system will be to render. And then you have colors, of course, so you can have a number of light and create something very interesting. Just with a number of different colors. And here I'm not using any material, so at the moment I have just added a couple of lights, well, 3 lights, in order to get this kind of lighting set. Now, what's happened when we start adding materials? So let's go to the ground. Let's add new material from here this time, and then we call it floor. And the first thing I'm gonna do is remove the roughness, and now you can see that I can see the lights because they are reflecting. I remove the roughness, so there's no more reflection. More roughness means less reflection. You can change the color, and of course will affect how the scene will look like, and you can make it metallic. Now, metallic, it means that the reflections are going to be tinted slightly depending on the light. Another thing you may want to enable when you have metallic surfaces, it's in the render properties, a setting called screen space reflections that will give you some, I would say, very approximate reflection, but it's good enough for most of the things we're gonna do. So, for example, if we go back to the material of the floor, if that wasn't metallic and was completely smooth, so you still see reflection, but you can clearly see that the reflection is not tinted as much as it's when it's metallic. Also, metallic, it's more reflective. And let's add back some roughness. And we are gonna add, we're gonna go to the shader editor this time, and we're gonna add something that we added yesterday that will give some kind of texture to the floor. So we're gonna select a noise texture again. There are many to play with, but we're gonna keep playing with the one we already know for now. And then we're gonna create a bump node. The bump is gonna connect to normal, and this to the height. And now we have something going on which is too big, so it looks like bumpy. That's good, but it's very big, so I want to make it smaller to get it rough. And then I'm gonna reduce the strength because I just want to create a fine texture. Let's make it even smaller. Okay. Now the first thing you can notice is that if I remove the roughness now, I don't have any more a clear reflections, but the reflection is basically rough because I added a real rough map. Imagine this roughness as a very fine roughness, while the map they can add details that are more noticeable. With the same material, with the same node, if you have actually something very big, let's say that we make it as big as it was, and then we increase the strength, and then we'll make it maybe something like that, and we created some kind of liquid pavement. So I'm mixing here some technique with light and some technique with the shader, because the shading, it's a mix of what you have in the scene object wise, what are the network of shading material, and what kind of lights you're using, because without the lights this scene will look completely different. If I remove this light, there's no reflection in the scene. The material is the same, but it's not working because the light is not good enough. In the same way, if I don't have a nice shader, I have a different effect. So the final result, it's a mix of all these factors. And also you notice how here having a different kind of color gives some more character to the liquid. It's not completely plain, it's not all the same color. If you would have, for example, very strong white light, completely white, strong, now it looks completely different. It's kind of a moonlight, I would say. You can also remove the shadow, it's even flatter. And that's why usually you use a mix of different lights and an HDRI, which is something that I'm gonna introduce to you in a moment. I'm just going to assign a new material to these blocks. Let's assign something that it's visibly let's just assign a checker or something like that, or the brick texture node. It's a simple brick texture creator. We'll just assign to the base color and will give me some texture. Now it's in the wrong orientation. I want this to be on the side, and there are different ways to change this. Yesterday we seen this briefly, but I'll show you again. I'm gonna create a texture coordinator node, coordinates node, and I'm gonna create a mapping, and then I'll go from object to here, and then vector to vector, and then now I can rotate by 90 degrees, and I have them on a side. I don't have them on the other side, and it will require some more work to do it, but for now let's keep it this way. Let me see if I can probably change something. No, it's not gonna work. I'm gonna show you in a future lesson how to have all the mapping in the correct orientation. Right now I just need something to show different material quickly. So let's enlarge this a little bit, and you can select some colors here to the brick. And then another thing I want is actually I'm gonna use the same pattern as a bump, so I will have some kind of depth to those bricks. So from here to height and normal to here, and then I will decrease a little bit, but you already see the difference. I can increase a little bit so you can see that more. And now if I decrease the roughness, and I need the light to work, let's say from the top. I don't know if you're able to see. Let's invert it so you can probably see the difference. Can you see that there is some kind of depth? Oh, let's increase it. Let me convert this to a different color so it's more it's clear what's going on. It's here, you can probably see that there is now some kind of border which wasn't there. So, but let's move on. We'll go back to the material. Now we need just something quickly to work with, and I'll assign the same material to the other one. Okay, actually I can bring them closer. You can see that here probably a bit better. Let me move this on the other side. Here now you can probably see better that there is reflections going on, and there is some kind of surface to it. It's not flat completely. So this is a way using point lights to illuminate, but another way it's using what is called HDRI, which is the same thing we have here. So here we are using HDRI that are default depending on the scene we want to work with. And if we go here, we need to add HDRI manually. And imagine HDRI, so if you click here and then go to world, you can add your own environment map. And HDRI is basically an image that is projecting lights from each point of a sphere. Let me show that quickly. It's probably better for you to understand this way. I click here on environment texture. It becomes all purple because it doesn't know what texture to use. You can download for free some texture. For example, if you go to HDRI Haven, it's a beautiful website with hundreds of HDRI to pick up from. And let's say that our scene now there is some kind of water. So I will go probably search something with water in it and see what do I get that I can use. Yeah, let's do something like this. From here you can download these images. There are 360 images, but they are saved in a format where the lights, it's first of all it's HDRI, it's high dynamic range images. So that means that there's more data than color in these images. They are saved with multiple exposure, and then the brighter light will go way beyond the visible light. They are just used to feed light information in 3D. Okay, let's say this: the bright lights will act as lights, and the darker area will be dark. But emitting light, that's what I'm trying to say. The bright lights, the bright parts of the image will emit lights. So here you can have a preview, and then you can download whatever is the resolution that you need. I would start with the 4K because it's enough for this tutorial for sure. It's saved in a format that's called HDR, and at this point I can open from Blender. Okay, I can open it, sorry, I'll open it from here, open, and I'll go to downloads, and there is my HDRI, click twice, and it loads in the scene. Okay, first thing is that you have it as a background. That means that if I rotate around, that was a 360 image, and the 360 image is in the scene now. The light in my scene, it's arriving from the light in the background. And you can clearly see here, I have shadow on this side, while here I have only reflections. If I put in the scene an object like this, you can see that here it's darker and here it's brighter. So it's getting the light exactly from the image. That means that it's much more realistic than having a light in the scene without any background. So if you're actually using the oh, thank you, Ganapathy. That's amazing. Thank you very much. I wasn't certainly expecting that. If you're using, for example, a studio environment where everything is dark and you only need some spotlight or some point light, or it's an abstract, it doesn't matter. If you're searching for realism, to have something that looks like a real photorealistic object, you may want to use HDRI, or mix them. Why not mix them both? Let me remove some of the reflection from here. Why I'm showing you this HDRI? Because I'm going to go back to the tutorial of yesterday to add a background to it, a real background. So yesterday I showed how to have a background, well, manually adding a sphere. So I added the sphere yesterday, I scale it, and now we have a background. Okay. The illumination of the scene is still coming from the HDRI that we picked, but I don't want to see that, so the quickest way to do it is having an object that will basically stop the background to be visible, still keeping all the kind of illumination. Yes, you can add an image as a background, but as the image will be completely, I would say, passive in the scene, it's usually something that you do in post-production. So you can save the image with a transparent background and then you add the image in post-production. Unless you are happy with the HDRI background, because maybe you get the right angle and you are happy with that, you can use that. For example, this is already a background image. Of course, our water, it's a bit too strong in color. Probably water has no such strong tint, but you can let's say adjust the water until it looks like the background and then use that as a background, for example. Another thing you can do, as this one is a sphere, but doesn't need to be a sphere, it can be another plane. So let's say we have this other plane here, and then we rotate the plane. No, it's rotating way too much, X 90. And then you have your physical background. And the advantage of having a physical background is that its position will move. So if you have an image in this background, the position will move relative to the foreground, so it will be a bit more realistic than having a static image in the background, especially in animation. If you're doing a render, a static render doesn't really matter, but if you're doing animation, you want that the background will move with animation. Okay, let's go back to our planetary system. Let's discard this, doesn't really matter. And yesterday we had this, and I created this sphere as a background. So now our background was basically the color of the sphere. While if I remove the sphere, you will see that there is this tint, which is a dark gray tint. And if I remove this and I put it back to black, I basically have not much going on in the scene. It's very flat. Okay, it wasn't using my parameter, that was kind of weird. So that was like this one, and if we put this to black as supposed to be the space, you don't see anything anymore. So there are different things we can do here. First of all, I'm gonna increase so I can see what I'm doing. If I load here an HDRI as I did in the other example, so environment texture, and let's open the same HDRI just for the sake of the tutorial. I have some kind of lighting, and I can also enable my background. So I have some kind of lighting, but it's completely, again, it's flat. It's good for an illustration, for a very simple illustration, but in space, it's unlikely that any planet will be illuminated on a side different than the sun, than the one facing the sun. So I expect these sides to be dark. So I cannot use really any background like this scene, because that's not how it works. In real life, we get lights from any surface. Any surface, it's a source of light. Outdoor, of course, it depends on the main source. It's the sun, if there is sun, and then if there are clouds, the light is diffused everywhere, and then even we get some kind of light from the ground. So what we can do, hello Techno, what we can do here is, first of all, ignore altogether getting light from an HDRI, because even if we get an HDRI that's like space, let's say that it's star, and we're gonna do that now, a background of stars, no planet gets any lights from any other star than the one in their own system. So in our case, we get only lights from the sun and the lights that it's bouncing off the moon. Anything else, it's completely pitch dark. So yeah, Techno, I could use space HDRI, but you don't get in real life any light from any other star than the one you are very close to it. So I'm gonna show you an example that's explaining what I'm saying. Let's remove this one that we just used, and we're gonna get another one. So let me go to already check that on Pexel. There is a random star field, okay, and it's a 360 image. It's important that whatever you use is a 360 image. Save this, and then let's import this in here. It's this one. They have a nice background. The stars are actually very bright, but they are not doing enough to illuminate my scene. And if I increase the strength of them, yes, they will finally illuminate my scene. but it will become a very diffuse lighting. There's no shadow here because there are too many, because stars are everywhere. So that's not how it works. So we're gonna use the HDRI as a background because I like the background, but we need to activate a real source of light. In our case, the real source of light in the scene, it's our sun. So let's go here so we can see what we are doing, and we enable all of that. I've disabled completely the background object, the sphere. We are not gonna use that sphere anymore. We are gonna use proper thing. Just remove it all together. So to recap, the background, it's an HDR image. That means that it's everywhere. No matter where I move, I can move in the scene, the background stays always there, and will just turn when I turn. And then I'm gonna add a real light in the scene. So in this case, as we are in space, that's nothing that can stop the light of the sun to go anywhere. The closest light source to the sun is not directional light, because the sun illuminates in any direction, but it's a point light. Okay, now the point light is there. Let me hide the sun so you can see the point light itself. Let me go in rendered, and it's not doing much, and that's because the point light is very, very faint. So we're gonna increase the power. It's certainly not 10 watts. I don't know what's the real amount. We didn't build anything in scale, so we're gonna increase the power of this light. That's probably a bit too much, but you're noticing what's going on. Well, let's start with 1000 and maybe a bit more. Maybe. Okay. So the first thing you notice is that, let me remove the background, but use the lights. The first thing you notice is that there are shadows. So this is only illuminated on one side. Okay, so half of it, as it's supposed to be, because it only gets lights from a direction. And everything behind this big Jupiter-like planet, it's dark because it's in the shadow of Jupiter. But let me remove this. But as the planet moves, you can start to see them. I will decrease a little bit the background because it's very strong actually. I just need some faint light in the background to make it realistic at the moment. So now Venus and Mercury are very close and they're glowing, so let me remove for a second the bloom effect. I don't know if you can see what's happening. So we have shadows, real shadows. You can see actually the moon, that depending on the position you see different phases of the moon too. And I didn't calculate anything here. I just put the right bits in the right place, and then as it's based on real life behavior, everything works. So you can clearly see all the faces facing the sun are illuminated. You can also see, look at here, there is shadow of this planet. I don't know, it's Mercury. When it's in that position, it's doing shadow on Jupiter and so on. Look at Saturn. Now there is some shade. Now the light is coming from here, but we remove the sun, because if I put the sun back, the sun is stopping the light to go through it. It's a real object, so the light is inside the sun, is not emitted from the surface of the sun at the moment. So we select the sun object, we go in the material, and down here we have the settings of the material that you can also find here. I'll show you in another place. Oops, too big. They are the same: settings, options, settings. You have the shadow mode. You can say, actually, the sun doesn't do shadow. Okay, none. That's it. You see, it changes automatically in both places. It's not opaque. It doesn't make shadow. If anything, it's a source of light. So this way, the point light, it's inside the sun, and it's passing through the object. Okay, while these other objects cast shadow. The sun doesn't cast shadow. The sun casts light, and then the other objects cast shadow. Okay, that's, you need to think about what will happen in real life with objects when you are designing with this kind of shading system. Now, what I see is that sun looks, actually, yes, it's bright, it's brighter than the other places, but it doesn't look lit. So I will re-enable bloom here, and I will increase the brightness of the sun. Probably I can put this down. Okay, that's probably enough to make it a bit glowy. And of course, if a planet is very close to the sun, it will probably glow. There's nothing I can do. Don't forget that I just put all the objects not in the right position, in the right distance, so they behave in a bit weird way. I can make it darker probably, so it will stop shining so much. Okay. And now if we go in the timeline again, we can play again, but with the sun enabled. And then we can remove the overlay. So, and this is in real time. I'm not rendering anything yet. This is all made by the system in real time. I need to spend a word about this render engine. I already said that before, but this render engine, it's a render engine that works like the game render engine. So the objects in the scene are rendered in real time, as much as possible in real time. Of course, it depends on the graphic card you have on your computer, but Blender, it's quite good. It's quite fast system. So it should work for simple things on any computer, really old. I was using a very old Mac till a few weeks ago. Difference with the other engine is that cycles, it's much more accurate than Eevee. So if you are rendering something that requires to be completely photorealistic, and completely photorealistic from a physics point of view, where each single refraction, each single shadow, it's exactly how they were, because you want to have a very photorealistic result, then you want to select cycles. But there are ways that you can achieve the same result even with Eevee. It's a bit more complicated, but it will cut away completely the render time because it's in real time. So it's worth learning how to do these things manually. If you think about all the newest video games, they have beautiful graphics and they are real time. So that's exactly what we are trying to do using Eevee. Look here, you can see even the shadow of Saturn in his own rings. Now, working a bit on the colors that right now are not very realistic. They are too strong. Probably the sun, we picture it yellow, but the sun, it's not yellow at all. The sun, it's white. So yeah, probably we can leave some. Now it's more like it. Plus, if you expose for the sun, everything else will be dark. So here we are mixing what's real and what not. And probably if you expose to see the planets in real life, the sun will be, well, it will be this, basically completely white blob. So the bloom is just the glow, and it's nothing that very important for editing. You can enable and disable it, and it will enable throughout the scene. So it's everything clear till this moment. I'm not gonna do much else with this scene. I just wanted to show how to import an HDRI, that in this case we are just using as a background, and we can increase the power of the HDRI. We don't really have this kind of thing. Usually when you are exposing on one star, everything else it's black, when you have a star this big and this close. But for making something cool, you can change the exposure a little bit. And also you can see from a distance, it's actually, let me remove some of the glow. But from the distance it's very interesting because this spot here, you cannot say if it's a star, if it's a planet. And that's kind of what happens in reality when you watch the sky. If something is very far, it's very tiny, you don't know what is it exactly, unless you know what you're looking at, unless you look at the movements and things like that. And if we zoom out even further, everything is part of the background. You only see that the star because you are closer to the star. But if I show you this image, can you tell me which one is closer? Yeah, that's exactly the point. It's not possible to say that without a system to understand the dimensions. So I show you now lights. I think the space is perfect to understanding lights because it's the simplest place light-wise. There's only one source of light. It's a point light, and will go without any stop, any shadow apart from the planet itself themselves. Now, if we watch from the top, as the top it's an orthographic view, the HDRI is not visualized. What we can do is flip a little bit so it becomes a perspective view, and then even if we are from the top, there's a minimal perspective correction, and you can see your animation from the top, which is 2D. I would say let's go from the top again. I would say this is a 2D animation. Technically it's a 3D, but the output it's 2D, plus we are watching from the top, so it's exactly what I would expect from a 2D animation. They're all sphere, so from the top they look all like circle. And I'm going to show you something more. And what I want to show you actually is what you can do with the background. Now, the background, as it's a node, first of all can be animated too, the HDRI, and we can also change some of the properties. Let me show what I mean. If we go in the shader editor, we are here in object mode. So we are looking at material that are related to the objects. If we switch to world, we'll see the nodes that are inside here, inside this tab nodes. And here we have an image. We could put anything as a background. We can put an HDR image, we can put a flat image. For example, if I put this one, now you have that image as a background. Doesn't make any sense, but it's just showing you that any image would work. It just wouldn't work well as a HDRI. But what you can do with this, it's applying all nodes that you have seen before. So we use, for example, the noise texture a few times, which means that you can apply a noise node there, and you can see now you have some kind of smoky, cloudy environment, and you can increase that. You can blend them together if you want to create some sort of galaxy clouds, but we're not gonna go there. What I'm gonna show you is how to change the color of the stars. So if we, for example, add a let's add a hue saturation node, which is exactly like the hue saturation in any other software. Now we can increase the saturation. Let me increase the strength so it's clearer what I'm doing. You can increase the saturation or remove the saturation. You see the color is changing. And of course you can make it darker, brighter, or you can change the hue altogether. So if you increase the saturation and you rotate this value, you see that they are changing color depending on how I'm rotating that. Let's put it back to normal. Let's put it back to 1. This means also, let's put it back to 10 so you can see them still. This means also that you can animate this value. Any channel can be animated, so I can do right click, insert keyframe here, and then move to the timeline. So let me open another let me open a different window. And here I'm gonna have my timeline. And for example, here the strength is 10. I can animate any source of light, any channel, any object position. So let me insert a keyframe here, and then I'll go to the end, and then I'll increase here the strength to this amount, and insert keyframe. And now you see that the power of the star it's increasing. Actually, you can have that increased in a very random way. So to create that flickering, I already published a tutorial, I think it's around 10 minutes tutorial about how to create the flickering of the space. I suggest you to have a look at that. Right now you know already, if you follow these classes, you know already enough to understand what's happening in the tutorial. But let me move this for a second. What we can do to complete this planetary system animation, let's keep this. I just don't want this. We don't have a camera in the scene, so let's create a camera. Let me put this to 0. I'm gonna create a camera. I'm gonna activate the camera view. The camera is quite close to the sun, so what I'm gonna do is click here, lock the camera to view so I can zoom out. Don't forget that you can change this, the viewport display, the passepartout, and make it completely black. You can realign the view. So if I click here, I can make it larger. This is what is going to be rendered. I lock the camera now, and then I'll go here, and I'm gonna insert keyframe here and here. Now it's facing the sun. The camera is facing the sun, and then I want the camera to go away while there are the revolution of the planet. So let me move this, let's go in preview, and that's how my animation will look like. Of course, you can reverse the animation, you can even just play that reverse. And that's kind of it for today. Unless you have any specific question, I will finish the lesson here, and we will have another one if not tomorrow, it's gonna be on Thursday, same time, and it's gonna be for well, we'll watch some other technique to animate objects and some other kind of objects. So we'll not go on from the planet example, we'll go into something completely new that will be closer to the main goal of this course. So it's gonna be about tech, I would say. We're gonna use clouds, we're gonna use connections, we're gonna create something a bit more dynamically. If you have any question, guys, please let me know. I'm still here. I'm gonna save this and include okay, all. Thank you so much for watching today, and we'll catch up tomorrow. I'll see you soon. Ciao, ciao.